The age of oil. Today, the fabric of world economy is based on the production of oil. Modern industry, upon which present-day standards of living rely, would not exist without fuels, oils, and other petroleum products. In establishing their Altona refinery in Victoria, the Vacuum Oil Company planned to assist the economic development of Australia by producing at first hand the refined products of petroleum. This is the story of the project for which Mr. H.C. Smith, Vacuum's operations director, was responsible. Between showers on the 19th of August, 1946, Vacuum engineers take the first steps towards the construction of Australia's most modern oil refinery on the 200-acre virgin site. Mr. A.M. Old, chief construction engineer, points out the boundaries to visiting American refinery technicians assisting on the project. Operations headquarters being erected is the same field office that was used in 1925 when Vacuum's ocean terminal and bulk installation at Yarraville was commenced. In a month's time, the foundations of 3 2-million-gallon crude oil tanks, each costing £17,000, are showing above ground. Others of similar size have been laid out. Working to a carefully planned schedule, workmen have almost completed the first base, which will support 8,500 tons of crude oil. At a very early stage in operations, the whole of the area was equipped with stormwater drainage. Mechanical excavators cut trenches to enclose large-diameter concrete pipes. With obstructions removed, pipe laying proceeded. Meanwhile, earth from roadway sites is removed by mechanical excavator. The total area is 11,500 square yards. Surplus spoil is transported to the nearby crude oil storage tank farm and used to form protective bunds around each 2-million-gallon tank. Across Coloroid Creek Road, excavating is taking place for the separator plant. Blasting is often necessary and customary danger signals given. The loading and carting of the broken rock is in itself a proposition. At the refining unit, the site is almost prepared for 8 large concrete pillars to support a 100-foot fractionating tower. The heart of any refinery is its fractionating tower, through which there percolates gases from heated crude oil to become plume motor spirit, mobile distillate, mobile diesel fuel, lubricating oils, and bitumen. The refining principle is quite simple. Crude oil from A is passed through the furnace B, where it's heated to 650 degrees Fahrenheit, before passing on through atmospheric fractionating tower C, from which the petrol fractions are recovered at point 1, kerosene at 2, and diesel oil at point 3. All these products pass through condensers D, E, and F, respectively. The reduced crude oil is passed back to another furnace B, where it's heated to a much higher temperature before being passed through vacuum fractionating tower G, from which is drawn light, medium, and heavy lubricating distillate from points 1, 2, and 3, respectively. These are passed through condensers H, J, and K, and then on to further treatment. Marketable bitumen is drawn from 4, passed through the cooler L, and into steam-heated storage M. Chemically treated lubricating oil distillates from fractionating tower G are further heated and passed into a vacuum rerun fractionating tower N. From this unit, light, medium, and heavy lubricating oil fractions are taken off at points 1, 2, and 3, then passed through condensers O, P, and Q, and then to storage. At point 4, fuel oil is drawn off and transferred to storage R. By now, good progress has been made on the product tank farm. Rows of sand-filled bases eventually will support product tanks up to 250,000 gallons capacity. The steel framework of a large engineering shop in the distance is well advanced. Other tank bases lie to the east. One of the tanks has just been started, and the first strake of plating is welded. A new plate is moved into position as a start on the next strake. The tank grows rapidly because the building program calls for completion within 5 days. This plate completes another strake, and when the process has been repeated once more, the tank will have reached its designed height and capacity. All tanks are built on billets of wood to enable anti-corrosive to be painted underneath. These 2 million gallon tanks are built just the same way. The round object near the jack is a safety ball sufficiently large to protect a man's body should any one of the supports collapse. After painting, the tank is lowered in stages. First, a point adjacent to supports is jacked up sufficiently to allow a 4-inch billet to be withdrawn. The process is repeated until finally the tank bottom rests on its base. 15-ton cranes like this one are used continually to handle steel plates weighing 1.5 tons. The diameter of this tank is 96 feet, and the area of its floor is quite sufficient to accommodate a full-size cricket pitch. From here, the refinery layout becomes more apparent. To the left are the foundations for the bases of 2 more crude oil tanks. In the far distance is the steel skeleton of the engineering workshop. Just this side of the workshop is part of a group of 28 tanks, ranging in capacity from 38,000 to 250,000 gallons each. Closer still are the foundations for the refinery's fractionating tower. And at the right are the excavations for the separator plant. But down at the tank farm, skilled craftsmen weld the plates together. This transformer station was an economic measure, the cost of its installation offsetting the cost of additional cables necessary to bring power of sufficient voltage to this corner of the refinery. Buried below the ground are over 3 miles of cables, which carry electric supply for the whole of the refinery plant. Victorian State Electricity Commission engineers laid the cables. No time is lost. Installations are covered, and as protective slabs are laid and bedded, a bulldozer follows up and fills in the trench. Nearby, roads to be made are surveyed and necessary levels taken. Number 1 storage tank is now nearing completion, although welding will take another 3 months to finish. Construction engineers proceed to create a huge spider's web, which will support a conical roof. On the actual refining site, comparable progress has been made, but there are many more product tanks to be built. One of the many alleyways formed by various groups of product tanks. From the top of the tank, it is possible to view another section of the refining area. Near the main entrance are the field supply stores. The main roadway is now in an advanced stage of formation. Across the top of the tank is seen the beginning of a roadway turntable for vehicles. The middle distance reveals further bases for tanks, and in the foreground, construction is proceeding. To the right of Williamstown racecourse, number 1 crude oil tank rears its steel head, but much closer are the bases for the fractionating tower and furnaces. Approaching these foundations are dozens of conduits for power cables. The administrative block is well advanced, and also near the main entrance stands the engineering shop, of attractive proportions and fabricated in Australian steel. Tall, wide doorways allow machinery to be moved in. The interior 2 months later. The carpenter shop also contributes to the construction program. In the middle distance, dozens of wooden billets to support the floor of number 3 crude oil tank are already in position. To the right is the sandblasting and galvanizing plant, where plates are treated to protect them permanently against corrosion. The plates are sandblasted thoroughly to render them suitable for treatment with galvanite. An air line to the operator's helmet supplies clean air slightly above atmospheric pressure, and spent sand is recovered and used again and again. Small plates are easily treated. Painting with galvanite is done by hand because the metallic content of the substance is too heavy for use in spray guns. Around the edge, a 4-inch strip is left until the plate is erected. When painted, the plate is moved into a stoving oven, where it remains for 20 minutes at a temperature of 350 degrees Fahrenheit. After that, the coating is hard, metallic, and impervious. As each plate weighs 1.5 tons, it has to be hauled into the oven with a compressed air winch. By now, further foundations for the condenser plant are being prepared. Concrete poured into molds is tamped home around steel reinforcing rods to form a support like the first one, which will carry a condenser weighing 20 tons. Meanwhile, considerable progress has been made at the boiler house. Assembly of water tubes of the 3 Babcock and Wilcox boilers is well advanced. With 2 boilers in position, another furnace is ready to be lined with fire bricks. Furnace building is fascinating. Many thousands of bricks of various shapes and sizes being used in each furnace. 3 steel smokestacks, 150 feet high, are necessary to carry away flue gases. Galvanized against corrosion, their installation calls for rare skill and dexterity. With the aid of a single mast and tackle and multiple manpower, the second unit is slowly raised into position. The tall, heavy smokestack is finally stepped on its masonry base, and the rigger comes down to earth. New landmarks on Altona's skyline. Throughout the building program, engineering supplies are the care of Mr. Van Cleft, while thousands of drawings and blueprints are the responsibility of vacuum draftsmen supervised by Mr. Evans. By now, the large water tube boilers are ready to be test fired. Pipes for supplying steam are carried by overhead gantries. Steam from the boilers is piped to bulk bitumen tanks, where it is circulated to keep the product at a temperature of 230 degrees Fahrenheit, ready for transfer to a reheater furnace. To insulate the bulk bitumen tanks, studs are instantaneously fitted by an electric stud welder. The arc is timed automatically, so that the correct degree of fusion is achieved, a modern technique for spot welding small studs. Then pads of insulating material 3 inches thick are added, and the studs turned over to hold them. The whole tank is soon covered, after which a metal sheathing is added. Bitumen transferred from insulated tanks must be reheated to 400 degrees Fahrenheit before delivery direct to roadway job by vacuum tank wagon. District Superintendent Mathewson of the State Electricity Commission tests switchboard circuits with Mr. McGregor, electrical engineer of Vacuum Oil Company. However, Mr. McGregor's chief interest is the low voltage supply obtained from another room. While next door, boiler attendant Taylor checks the lubrication of his air compressor. Considerable progress has now been made at the separator plant, where large quantities of reinforced concrete will be used to form the sump and foundations. Here, used water is to be treated before being discharged in a perfectly clean condition into the sea. In its finished state, this water purification plant provides an inspection walk between the separator channels. Large quantities of seawater, 1,200 gallons a minute, are circulated by electric pump or emergency diesel power. Number 1 crude oil tank is now completed, and a protective bund is constructed around its base. An 8-inch pipeline will bring crude oil from the oil wharf 4.5 miles distance. Large bends are included to provide for expansion and contraction of the metal. First cargo of crude oil for the tank. Wharf hoses are coupled up while the chemist takes samples. After quality has been certified, Mr. McVean, works foreman, opens the discharge valve, while Refinery Superintendent Cruikshank discusses progress with Mr. A. Chapman, vacuum shipping manager, and tanker Captain Graham. To heat the crude oil, 2 furnaces are required. The same unit nearing completion. At Steel Wells Proprietary Limited, Braybrook, the first pipe still is almost ready for the refinery. And one of many bubble trays is assembled and checked for proper fit. About the same time, another large pipe still was manufactured by Thompson's Foundry at Castlemaine. This pipe still is delivered by special transporter to take its place beside the others. Yellow Express executives maneuver the 38-ton pipe still into its elevating cradle before being carefully raised with the aid of a portal derrick, and 4 manually operated windlasses placed about the tower's base. An anxious time for senior civil engineer Alf Chaffee. A little at a time, the men on the winches bring the heavy unit higher and higher. There's no hitch, and finally the 69-foot pipe still is snugged into position alongside its companion. Everything is now ready for decking to be added to the tower, and supply and draw-off pipes to be fitted. From one pipe still, light oil will be produced. The raw products are further refined in treatment plants, carefully controlled. Other products are further refined in the acid treatment plant, where control valves form a formidable array. These products are transferred by electric pump to the lubricating oil blending plant and afterwards packed for sale. Closely associated with the construction program were Mr. S.G. Cruikshank, refinery's first superintendent, and Mr. J.B. Pierce, refinery accountant, aided by a specially trained staff. By early June 1949, all main units of Altona refinery are almost completed, and with the exception of some brickwork and essential painting, the fractionating tower is practically ready to receive the first crude oil from the completed furnaces. Visitors from overseas. Mr. H.W. McCobb, Director of Standard Vacuum Oil Company, and Mr. R.N. Keppel of Standard Vacuum Oil Company, New York, accompany Mr. Harold Rabling, Chairman and Managing Director, and Mr. H.C. Smith, Operations Director of Vacuum Oil Company, to inspect the 14,000 pounds worth of instruments in the control room. On the 24th of March, 1948, a memorable ceremony took place in the presence of government, civic, and industrial leaders, when the Honourable T.T. Holloway, Premier of Victoria, complimented the Vacuum Oil Company on their outstanding contribution to the industrial resources of Australia. Also present was Mr. F.H. Bedford, Jr., a Director of Standard Oil Company of New Jersey. At the invitation of Mr. Harold Rabling, Chairman and Managing Director of Vacuum Oil Company, Mr. Holloway unveiled a commemorative plaque. Altona Refinery. To the engineers and workmen who assisted in building this plant, Vacuum Oil Company pays grateful tribute. A challenge to Australian initiative and ingenuity, Altona Refinery is a monument to their skill and resourcefulness in an engineering achievement of which they may well be proud. Altona Refinery is another milestone in the Vacuum Oil Company's great record of service to Australia and emphasizes the company's status as a leader in industry and commerce. And so, a refinery is built.